Interpreting tornado, change in output mean. This tornado is a favorite one. Many decision makers like it because it can be expressed in the currency of the measured unit of the output variable and not with a coefficient. Some decision makers find it difficult to interpret a correlation or regression coefficient. After the simulation has been run, the tornado chart should look like this when opening it with the Browse Results button. The baseline is the overall simulated mean of that output. Each one of the bars represents an input and has two numbers on its edges. When calculating these two values, one input at a time, all other inputs are ignored. In other words, these other inputs are not held constant. Their values from the simulation are simply not used in the computation. Next, at-risk puts all the iterations in order by ascending values of that input. Then, at-risk divides those order iterations into 10 bins. The number of bins can be changed if desired. With 10,000 iterations, the first bin contains the 1,000 iterations with the 1,000 lowest values of this input, and so on to the last bin, which contains the 1,000 iterations with the 1,000 highest values for this input. On the following step, at-risk computes the mean of the output values within each bin. Finally, at-risk places the lowest of the 10 output means as the number at the left edge of the bar for this input, and also places the highest of the 10 output means as the number at the right edge of the bar. The key here is that the inputs are first sorted in ascending order and binned in that order. Then, an output mean is computed for just the iterations in each bin. Differentiating shows which end of each bar represents high input values and which represents low input values. Therefore, you can easily tell which inputs have positive impact on this output, high inputs at the right, and which have negative impact, high inputs at the left. The change in output statistic tornado does not measure the influence of any input on the output. The numbers are purely statistics based on two parts of the simulation. One end of the bar is the mean of the output values from the iterations with the lowest 10% of input values, and the other end is the mean of the output values from the iterations with the highest 10% of input values. For example, observe the first bar for weather-related delays. It contains two extreme values at approximately $110,000 and $130,000. When weather-related delays occur at their bottom 10% of their low values, then the mean total project cost will be of $110,000. By the same token, when weather-related delays occur at their top 10% of their high values, then the mean total project cost will be of $130,000. No other variable has a larger impact on their extreme outcomes as this variable has. Now, observe, for example, activity 5 bar on this tornado graph. If you only consider the bottom 10% of their simulated values, total project cost will have a mean value of close to $117,000. If you only consider the top 10% of their simulated values, total project cost will increase to a mean value of slightly less than $119,000. In other words, it shows a total variation of less than $2,000 when considering rather extreme values for activity 5, compared to a $20,000 difference for the top bar of weather-related delays. 90. Click on the tornado icon at the bottom of the graph window and select Settings. This will set the preferences for a particular Browse Results graph by changing parameters on the following window. For example, change the statistics to calculate the output from mean to percentile 5. You can display a change in output percentile rather than a change in output mean. In this case, the computation is similar, but instead of an output mean for each bin, at-risk computes an output percentile for each bin. For example, with 10,000 iterations and 10 bins, if you select change in the 5th percentile, then at-risk will compute the 5th percentile of the output values within each of the 10 bins, within each group of 1,000 iterations sorted by input values. And the edges of the bar will be the smallest and largest of those 5th percentiles. The baseline of the output becomes the overall 5th percentile of the simulation. You can observe that the relative order of the bars in this chart changes. Activity 4 now becomes the top bar on this tornado. This means that with respect to the 5th percentile of total project cost, activity 4 is the one variable that, when evaluated on its extreme bottom and top subsets, will have the largest impact when compared to other input variables. 91. You can also change the number of bins or scenarios used to split the extreme tails of the analysis. On settings, change back the statistic from the 5th percentile to the mean and change divide input samples into 20 scenarios. The numbers on the top bar for weather-related delays has changed again. The interpretation is as follows. If you only consider the bottom 5% of their simulated values, total project cost will have a mean value of close to $109,000. If you only consider the top 5% of their simulated values, total project cost will increase to a mean value of slightly less than $133,000.